The James Webb Space Telescope has recently turned its gaze toward L98-59d, an exoplanet approximately 35 light-years away, orbiting a small red dwarf star in the constellation Volans. This distant world has captivated astronomers due to compelling evidence suggesting it may possess a thick, sulfur-rich atmosphere potentially fueled by intense volcanic activity. In this video, we'll examine the methods behind this discovery, the scientific debates surrounding it, and recent relevant discoveries that broaden our understanding of such phenomena. The discovery of L98-59d's unique atmosphere is a significant milestone in exoplanetary science. Researchers led by Banerjee used Webb's near-infrared spectrometer to analyze light from the exoplanet as it passed in front of its star, revealing spectral signatures associated with sulfur dioxide and hydrogen sulfide. This method, called transmission spectroscopy, allows scientists to infer the components of an exoplanet's atmosphere based on how it filters the star's light. The presence of sulfur dioxide and hydrogen sulfide suggests that this exoplanet may experience substantial volcanic activity. Typically, sulfur compounds are tied to volcanism, indicating that intense volcanic eruptions could be replenishing its atmosphere with sulfurous compounds. This discovery is particularly surprising due to the exoplanet's proximity to its star. Planets so close often lose their atmospheres due to intense stellar radiation. Yet this exoplanet's potential volcanic activity seems to counteract this effect, helping the planet maintain a dense atmosphere despite harsh conditions. Drawing a parallel with our solar system, this exoplanet is reminiscent of Jupiter's moon, Io, the most volcanically active body in our neighborhood. Io's intense volcanic activity results from tidal heating caused by gravitational interactions with Jupiter's and its neighboring moons. This process creates internal friction, heating the moon's interior and driving volcanic eruptions. Scientists believe similar tidal forces may be at work within the exoplanet, possibly triggered by the gravitational pull of nearby planets in the system. This heating could generate a volatile, sulfur-laden atmosphere similar to Jupiter's moon, helping the exoplanet retain a thick, sulfurous layer around it. Despite the excitement, the scientific community has approached the discovery with cautious skepticism. The data captured by Webb, while compelling, is also described as noisy and tentative, leaving room for alternative explanations. Some astronomers have raised concerns about the possibility of stellar contamination. Signals from the star itself can interfere with the data, making it challenging to differentiate the star's emissions from the exoplanet's atmospheric composition. This issue has been encountered before with exoplanets in the TRAPPIST-1 system, where signals from the star affected conclusions about their atmospheres. Additionally, the lack of certain volcanic gases, such as carbon dioxide and water vapor, has raised questions. In most volcanic systems observed within our solar system, these gases are prevalent, even more so than sulfur dioxide. For instance, volcanic eruptions on Earth and Venus release significant amounts of carbon dioxide alongside sulfur dioxide. On Io, water vapor is less present due to the moon's dry environment, but many astronomers would still expect carbon compounds if the atmosphere were volcanic. The apparent absence of these gases in the exoplanet's atmosphere challenges the volcanic hypothesis, leading scientists to wonder if something else could be responsible for the sulfurous composition. Furthermore, the exoplanet's proximity to its star might lead to atmospheric erosion, with the sulfurous compounds representing remnants of a larger, more complex atmosphere. This erosion effect is common for planets orbiting red dwarfs, which emit intense radiation that strips away atmospheric layers. Thus, the sulfur-rich atmosphere on this exoplanet could reflect only the most resilient compounds, while lighter gases like hydrogen escape into space. To validate or refine the findings about this exoplanet, astronomers are planning a series of follow-up observations using Webb's additional instruments. These tools will allow researchers to examine the planet's atmosphere at different wavelengths, helping to clarify its composition and confirm the presence of sulfur and other gases. Adding to this exciting area of study, discoveries of similarly volcanic exoplanets, such as LLIP 791-18d, highlight the unique possibilities within distant systems. In May 2023, astronomers identified ELP 791-18d, located about 90 light-years away, which may also be volcanically active due to gravitational interactions with nearby planets. This discovery indicates that tidal heating can drive volcanic activity on exoplanets much like the one we just discovered, supporting the idea that gravitational forces might be fueling its sulfurous atmosphere. The relevance of these findings is underscored by Webb's detection of sulfur dioxide on another exoplanet, WASP-39b, in November 2022. WASP-39b is a hot gas giant, not a rocky world or exoplanet, but the detection of sulfur dioxide marked a breakthrough in Webb's ability to identify complex atmospheric compounds. By studying sulfur dioxide and other gases in exoplanet atmospheres, astronomers can better understand how volcanic activity and photochemistry influence planetary environments. If future observations confirm L98-59D's volcanic atmosphere, this planet would join the ranks of known exoplanets with active geological processes, offering astronomers an invaluable case study for understanding the mechanisms that shape planetary atmospheres beyond our solar system. This could provide new insights into the diversity of planetary formation, as well as the potential habitability of planets orbiting red dwarf stars. Thank you for joining us on this journey through the cosmos. Stay tuned for more updates on the fascinating world of exoplanetary science. Don't forget to like, subscribe, and share this video with fellow space enthusiasts. Until next time, keep looking up.